Here's another video on the 5-a-day series, and today we are looking at this is 11 Jan, and this is grade 8, grade 9 topics. So the first one is loss of indices question. The first thing that kind of is screaming at you is to kind of sort out the numerator or the brackets. So we have 6x to the power of a half, and this is being cubed. So obviously we're going to have to distribute that power onto the first person and also to the second person. So the 6 gets the cube, becomes 6 cubed, which is 216. And when the x to the power of a half gets another power, remember power of a power, you times them together, so a half times 3 over 2 becomes x to the power of 3 over 2. So the first thing that we did there was distribute the powers to both of them. In the denominator we've got 2x, so we're going to do the numbers first, 216, and then divide that with 2. That would be 108. X to the power of 3 over 2, division, we're going to subtract the powers, so 3 over 2, take away 1, that will be 1 over 2. So your answer would be 108 x to the power of a half. And that's your first question. So please do not straight away cancel out the 2 and the 6. You first need to deal with the brackets in the numerator. Then once you've done that, then you get to doing the simplification on the denominator. Next part is work out this mixed number. So I kind of think it's much easier if we get this into a top-heavy fraction or an improper fraction. So 11 over 25. If I convert that to a mixed number, that will be 1 times 25, which is 25. Add 11, that is 36. And I've got 36 over 25. So we're going to rephrase the question as 36 over 25 to the power of minus a half. What we're going to do is, when you see a negative power, always remember, negative powers mean you flip the question. So 36 over 25 becomes 25 over 36. And then the negative power turns into a positive power. So this becomes a half. Now, a half simply means we're doing square root. So we're going to get, if you take the square root, so that would be 5. This would be 6. So your answer would be 5 over 6. Yeah, so that's basically that. So power of a half is basically square root that. So whenever you see a negative power, flip that, turn the negative power into a positive power, and then basically, yeah, that's it, you're done. Next one, we've got a quadratic inequality. So the first thing that we do, so quadratic inequality, first thing that you do is you would factorize this. So just like your normal quadratic equation, let's first try to factorize this. So 2x squared, 2x squared minus 5x plus 3. So we're going to multiply the 2. So that would give us x squared minus 5x plus 6. And this is one of those confusing ones. People tend to do 1 and 5. Sorry, yeah. 1 and 5, 2 and 3. Yeah, 2 and 3 would be the right one. So please do not go for 1. Sorry, I'm not saying 1 and 5. I should have said 1 and 6. Yeah, please do not go for 1 and 6. It is 2 and 3 because you need a positive 6 in your answer. So this would be x minus 2 and x minus 3. So you have to be careful when you have a negative in the middle and a positive at your last term. It might be, slightly misleading, so just be careful. And then because we multiplied by a 2 at the beginning of our answer, we're going to divide by the 2, and that would give us x minus 1 and 2x minus 3 less than 0. One thing that I would always recommend is just multiply the first term and the first term. You get 2x squared. That's good. Multiply the last and the last. You get plus 3. That's one quick check that you can do just to check if you have done the factorizing correctly. So first step was factorizing. Step number 2 is you need your diagram. So we're going to draw a diagram now, which is, now we know this is a positive quadratic. So if you want to draw your positive diagram, your diagram, you need the roots or your x-intercepts. So if you want to find your x-intercepts, we know that's straightforward. So this would mean x is equal to 1 or x is equal to 3 over 2, which is 1.5. So the two roots or the 2 points that we are interested in is one is 1 and the other one is 1.5, and we know it would be a positive quadratic. Should we start? I hate myself. I'm sorry, I'm a bit clumsy with the pen. Let's, okay, I'm just gonna put the X mark there. And this is the number 1. Now, what I would recommend you to do is imagine this as the C, and when you read this, how do you read this inequality? 2x squared minus 5x plus 3 is less than, right? Less than would mean you want to go down or under or below. So think below sea level. So if you're thinking below sea level, you're talking about everything that is under the sea. And where are you under the sea? You are under the sea when you are in between. Now, in between 1 and 1.5. So think of the x-axis as the sea. If your question says less than, meaning you go under or you go below, where do you go below the sea when you're in between a 1 and 1.5? The inequality that you have is a strict inequality. There is no equal sign. So you're going to write 1 is greater than, 1 is less than x, which is less than 1.5. And that would be your answer. Now, the mark scheme sometimes says you could also mark your answer on a diagram. But if you know the diagram, it's much easier to do it one line of working, and that's it. So that's the quadratic inequality. So first step is the factorization, second step is the diagram. Then think of the sea level. Do you want to be above the sea level or do you want to be below the sea level? And that's your answer. Next one, again, we've got a histogram question. In a histogram question, I want you to remember area of the rectangles is equal to the frequency. So let's see what the question is telling us. We do not know what is the frequency density or the heights of any of these bars. You can assume that, this is 1, this is 2, this is 3. But remember, I think there was one of those questions, I think yesterday or the day before, where we did this as 2, 4, 6, 8, and 10. So we're not really sure what exactly or how are the numbers going up on the y-axis. So what we're going to do is, we know that 14 cars were traveling over 50 miles. That is the only piece of information that we know. So what we're going to do is, let's try to find the area of everything that went above 50. So I am going to assume, so 50 to, so the rectangles are going up in tens. So this right here, maybe I should use a different color. This is half a box. So if it is half a box, I know the base of that rectangle, or the base of that rectangle is 5. Now, I do not know anything about the height of that rectangle. So what I'm going to do is, I'm going to assume it is 1 box, 2, 3, 4, and 5. Okay, now comes the tricky part. What we are going to do is, let's calculate the area. This is 2.5. So for the first rectangle that I've got there, I've got the base as 5 and the height as 2.5. So I know the area of this one would be 5 times 2.5. That would be 12.5. Okay. Similarly, let me try to find the area of the second rectangle. So the second rectangle, I know it's one full box. So the base is 10 and the height is only 0.5, right? Because it's only half of that. So that would be just a normal 5. So what we have here is, if I add these two areas, it would be 12.5 add 5, and that would be 17.5. So I want 17.5, which is my area. However, that's not equal to the 14. What we're trying to establish is the area that I found out should be equal to the frequency, which means the area number 1, which is 12.5, and area number 2, which is 5, when I add them together, I should be getting 14 and not 17.5. So what we have there is some scaling factor or a proportionality constant. So I asked myself, what can I times, or if my area is 17.5, how would that be equal to 14? What can I do to get to 14? So another way is, let's say, I know if I get my area, I should multiply that with something to get to the frequency. The technique that we're doing is, because our area doesn't match with the frequency, we are bringing in some scaling factor or some number that would actually fix my area in such a way that area would actually be equal to frequency. So we need to find that value k. So obviously 17.5 times by k would give me 14. So I know k is equal to 14 over 17.5. So this is that number which would then fix my area in such a way that it kind of becomes the same thing as the frequency. The reason why we're doing this is because I didn't know what are the numbers on the y-axis. I just assumed them to be 1, 2, 3, 4, 5, and that is why I kind of ended up with the wrong area. But I can fix it by bringing in that new number k in such a way that the area now becomes the same as the frequency. Okay, so I've kind of fixed it. Now the question says, calculate an estimate of the number of cars that were traveling between 42 and 49. Oh, they've made our lives much difficult here. So we need to find between 42 and 49. So between 42 and 49. Let me zoom in for you guys. So if I need to find 42 and 49, obviously we know that there are 10 divisions here, so we know each of them would be 1 each. Right between the middle, we can find 45. So I know there's 45. So 42, if I draw a rectangle there, I'm hoping you might be able to understand. I might get a thinner rectangle with the same height, which is 4.5. Okay, so what we're going to do is, let me draw that rectangle for you. So I've got a rectangle here which starts at 42, ends at 45, and the height of that rectangle is 4.5, which means the base is 3, and I can do 3 times 4.5, and that would be 13.5. So I've got the area of my first rectangle. Now I need 45 to 49. So let me draw another one from 45 to 49. And the height of that rectangle would be Obviously it's not as tall as the first one. So let's go and check how tall is that one. So the second one is here, which is 3.5. So the second one is 3.5. So the height is 3.5. And obviously this one is 4. So 4 times 3.5, that's 7. And this would be 14. So I've got two areas here. One is the 13.5, and this would be 14. So if I add them two together, I'm going to get 27.5, right? Now, in a normal question, area would be equal to your frequency, but remember, here we need to get that number to fix our area, and the number that we need to fix our area is K, which is 14 over 17.5. So if I bring in 14 over 17.5, and if I grab my calculator, let me times them together, we would get, okay, let me just show it on the, so 27.5 times 14, let's see if I have classpad, clear, where is clear? Yeah. So 27.5 times that by 14 and then divide that with 17.5. Do we get a nice answer? Yeah, there we go. We get 22, so the answer would be 22. All right, so these are grade 9 histogram questions, and the technique here is, obviously they haven't told you what the frequency density is or what the height of those rectangles are. So obviously you have to assume area is some number k multiplied by the frequency. And the reason why we're doing that is because I just assumed the numbers are going up in 1, 2, and 3. We kind of ended up with the position that 17.5 had to somehow equal 14. So I brought in a scaling factor, which kind of adjusted the area to the frequency. Then we found the area of what we were looking for, and then multiplied it by the number k, and we got to the frequency. Right, so I hope that made sense, and that is our 5 questions for the 11th of Jan. I'll see you in another video. Take care, bye bye.